Hello. Hello and welcome to this video on XML functions. So we will wrap this theory part of XML functions of PostgreSQL documentation in this video. And in the next video, I will show you an example of all these functions in great detail. So let's continue the read through and we will finish this today. So section 9.15.4 is about mapping tables to XML. The following functions map the contents of relational tables to XML values. They can be thought of as XML export functionality. Table to XML takes argument as a table, nulls, table forest, target namespace, and returns an XML. Then we have query to XML, which takes query. Other arguments remain same, gives an XML. Cursor to XML takes a cursor, count, nulls, and other arguments are the same. So table to XML maps the content of the main table passed as parameter table. The reg class type accepts strings identifying tables using the usual notation, including optional schema qualification and double quotes. Query to XML executes the query whose text is passed as parameter query and maps the result set. Cursor to XML fetches the indicated number of rows from the cursor specified by the parameter cursor. This variant is recommended if large tables have to be mapped because the result value is built up in memory by each function. If table forest is false, then the resulting XML documents look like this. Your table name, row, column name 1, column name 2, and so on, and each column name contains the actual data. If table forest is true, the result is an XML content fragment that looks like this. Table name, column name 1, data, column name 2, data, and finally it ends with the table name, and then again begins with table name and table name. If no table name is available, that is when mapping a query or a cursor, the string table is used to the first format, row in the second format. The choice between these formats is up to the user. The first format is a proper XML document, which will be important in many applications. The second format tends to be more useful in the cursor to XML function if the result values are to be reassembled into one document later on. The functions for producing XML content discussed above, in particular XML element, can be used to alter the results to test. The data values are mapped in the same way as described in the function XML element above. The parameter nulls determine whether null value should be included in the output. If true, null value in the columns are represented as column name xsi colon nil is equal to true, and it's a self-closing tag, where xsi is the XML namespace prefix for XML schema instance. An appropriate namespace declaration will be added to the result value. If false, columns containing null values are simply omitted from the output. The parameter target namespace specifies the desired XML namespace of the result. If no particular namespace is wanted, an empty string should be passed. The following functions return XML schema documents describing the mappings performed by the corresponding functions above. Table to XML schema. So similar argument as table to XML, query to XML schema, cursor to XML schema. Similar arguments are there. It is essential that the same parameters are passed in order to obtain matching XML data mappings and XML schema documents. The following functions produce XML data mappings and the corresponding XML schema in one document or forest linked together. They can be useful where self-contained and self-describing results are wanted. Table to XML and XML schema, and query to XML and XML schema. In addition, the following functions are available to produce analogous mappings of entire schemas or the entire current database. The schema to XML takes schema name and other arguments are same. Schema to XML schema, similar arguments. Schema to XML and XML schema, same arguments. Database to XML, nulls boolean, table forest boolean, and target namespace is taken and output is XML. Database to XML schema and database to XML and XML schema. These functions ignore tables that are not readable by the current user. The database-wide functions additionally ignore schema that the current user does not have usage lookup privilege for. Note that these potentially produce a lot of data which needs to be built up in memory. When requesting content mapping of large schemas or database, it might be worthwhile to consider mapping the table separately instead, possibly even through a cursor. The result of a schema content mapping look like this. We have schema name, table 1 mapping, table 2 mapping, and so on, closed by schema name. But the format of a table mapping depends on the table forest parameter as explained above. The result of a database content mapping looks like this. You have DB name, schema name 1, schema name 2, and so on, where the schema mapping is as above. As an example of using the output produced by these functions, example 9.1 shows an XSLT style sheet that converts the output of table to XML and XML schema to an HTML document containing a tabular rendition of the table data. In a similar manner, the result from these functions can be converted into other XML-based formats. So this is our XSLT style sheet, and it will require knowledge of XSLT style sheets so that you can understand. So these are the namespaces of style sheet, and the output method is XML doc system, and all are mentioned here. So first you match everything, and variable name is schema. We select this particular tag, and then variable name is table type name. Schema is what we match here, or rather this variable. And then you can go ahead and read about this. Actually, it is best if you can experiment with this. I do not have the actual data to show you that how this will work. Okay, let me, this is XSLT style sheet. So it will be difficult for me to show you how this XML is converted to HTML. Let me give an example. Okay. So if you don't know what an XSLT is, let me show you. So let's look at my book on coordinate geometry. Okay. And if you look at SRC here, so these are the XML documents which describe the XML data, which will be in your case the database data. So for example, the root file is cg.xml. So this you can see in this here. So it's a book. So this is the book tag, and these are the namespaces and XSD files, docbook files mostly, and mathmal. And this is the actual content. Okay. Now what happens is that it is processed by this make file. Sorry, it will be in parent directory make file. So if you look at this particular line here, you will see that it is processed against an html.xsl. Now if you look at html.xsl, so it will be also in the parent folder. So it uses a standard XSLT style sheet, this file. Okay. Let me see if I can copy this, and let me show you the actual XSLT file. So, and when dot flash, sorry, okay. So HTML, and then you will have chunk. So this is the one which is being used right now. Now, if you see this, it further includes two different XSLT, chunk common and chunk core. Now, if you look at chunk common, it further dictates how the files will be converted. Okay, so these are the rules, and it can be quite complex. XSLT are complex business if you really want to do everything into XML to XSLT. You can see that it is quite big. It is roughly 2000 lines. And then we look at what was the other one? So other one was docbook. Okay. So we open docbook.xsl, and it includes several other XSLT files. Okay. So if you want to actually look at it, so effectively everything in this folder will be used, almost everything. So if you want to see that how much it is there, so XF itself is 47 kilobytes, verbatim is 14 kilobytes. So it is quite a bit of documentation. For example, param.xml is 300 odd kilobytes. Title page is 196 kilobytes. So XSLTs can be quite complex, particularly docbook one is quite complex to convert XML files into HTML. For smaller kind of HTML, docbook is a big thing, okay? It's a big specification. This XSLT relatively is quite simple, but I don't have a table ready for you to show you the structure, okay? Let me try to no, creating data will not be possible. Okay, so we will skip this. This is actually also outside the scope of the database knowledge. It falls under web development and XML processing knowledge. So I can't really go into XSLT discussion. So what you can do is if you want to learn about XSLT, so the best or the easiest resource would be W3 Schools. And you go here and you read all this stuff about XSLT, and XQuery will also be required for understanding the XPath. XPath will be also required. So once you go through XPath, XSLT, and XQuery, you'll understand how these are actually going to work out in combination. So I can't really go into details of XSLT. Even if I explain it to you, if you don't know, you would have a hard time understanding what I'm talking about. Okay. So there's no point doing that. And it was a short video relatively because there was not much content left to help you understand the behavior. So basically what I'll summarize for you, okay? So in any XML, basically there are two things, okay, or rather three things. One is the tag, another is the attribute of the tags, and the third part is the actual content of the tag. So an XSLT document basically takes out those elements from the tags and attributes and what we call tags, attributes, and content. Let me give you one example here, concrete example. So let me show you, that will be the best way to explain it. So for example, if you look at this file and when dompy.py. So right now it is not there, but in programming books I do that. So you see that it is looking at this free C lecture. Okay. So what I do is that in program listing tag of docbook, I give a role C lecture. That comes out in the pre tag in HTML after processing from docbook. And I pick up that tag and I apply highlight on that. So it formats according to C language. Okay. So further, if you see that highlight string takes a C lecture argument. Okay, this is a valid uh, formatter in highlight pigments. Basically, pigments gives you this C lecture, and then C obj dump lecture, make file lecture. These are lectures of pigments. So as you can see from pigments.lectures, I import those, and highlight function is from pigment.lecture. Now I'll give you another example. This is not really XSLT example I gave. Now I'll give you an XSLT example. Okay. So what you call the word is I forgot the word. Okay. So in docbook, mathematics is represented by MathML tags. Okay. Now, I don't do that because I want to produce server-side rendered content using MathJax, and I want to produce DB LaTeX uh, files. So what I do is I use M tag and put LaTeX equation inside dollar. So what you are looking at here is I match at M tag here. That will match the M tag. And then it will write this text. And then it will take the value of the select, that is whatever is inside M, it will put it there. Okay. and finally it will close it with the closing brace because I want color to be closed out. Okay, and that's how I do it. So this will look for any mathematical content, and within these text it will put it that way. Now section blue, if you see what is that, section blue is a color in LaTeX. Okay, this is the LaTeX color defined, and this will apply only to DB LaTeX. Okay, so you will see what M tag does here is, if you look at the src say coordinates.xml, okay, vi is not installed. So let me show you, this is a match tag. So it will take this content, these three characters, and put left brace, color, section blue, and then this text followed by a closing brace. So it will be highlighted with green color and match mode in LaTeX, because LaTeX will take dollar as math. Now that is one part of the thing. Now the other part, if you see the processing part of this, that is done in sr.js. So this also looks for match tags. So M tag, when it will look for dollar dollar, okay. And let me show you html.xsl. Okay, and when so again here I'm looking for the same match tag, and I just take the content and paste it there, just that, thereby removing the M tag. Okay, once that is done, I go through the regular expression. This is a crappy regular expression, but it works. Okay, can be improved. And then I take the fact that whether it is inline math or display math, and I go and apply the MathJax server-side routines in this. So this adapter is actually a MathJax adapter, as you can see here. Okay, let me show you at the top. So these are MathJax objects which I create, and then I process using MathJax. So that's how I write book, and that's how I convert XML to LaTeX. I use DB LaTeX, and I use XSLT proc and the docbook style sheets for HTML. So fundamentally, using XSLT, you can translate XML to almost any format. You can translate it to JSON, you can translate it to Markdown. Any kind of conversion you want to do, you use XSLT to translate XML into any kind of desired format. So that's the whole thing about XSLT. I went too far ahead from the actual discussion of databases, but that's what I wanted to do for explaining the XSLT side of it. Not really wanted to, that is what happened actually. Okay, so if you really want to understand that how this particular thing works, you need to go to that link I gave you, W3 schools, go through those three sections, and then you will be able to understand what is going on here. Okay, so for example, let me, no, not for example. I'm not doing it. Explain this will not make sense, but anyway, let me show you how it structures basically the HTML. So you see this HTML format, it is outputting, okay? And then your title is value of some node selected. Then in the row type name, it formats the tr, okay, thead. Thead is basically row type name, okay, that's what will go here actually. And for each row, it will select everything and put it inside td. That's the whole essence of this XSLT file is. So the column names of the row will go and become the table header, and each row's content will go into individual cells of the table. So that's what it is, nothing more. So with this, I will end this video here. I hope that you have enjoyed this video more than the database side. I hope that you have learned something about XSLT. Let me show you an example actually. W3 schools was good enough. I shouldn't be doing that. Okay, let's see. Okay, so let's take an example. Okay, so let's go here, try it yourself. Now see, this is XML file. It has a catalog root tag, cd is there, Titles, artist, country, company, price, year are there. So there are multiple CDs here, several CDs. So each have the similar stuff. And what it does is, the XSLT, what it does is it prints HTML body, okay? And then it gives a header, my CD collection, and table border and TR and all that is fine. So this is the header is created, okay? Title and artist. All right. Now, if you see this, title and artist are there. Now, the actual thing happens here. XSL for each select catalog slash CD. So you are looking at each CD. Okay, catalog CD means each CD for each. It takes the value of title, that is this, okay, and puts it in that, and the value of artist. That's all it is doing. So let me show you something here, okay. So this table header, I can put anything, okay, th style is equal to whatever. I don't want to give style, okay, I just want to type some garbage. And here, I actually want to copy this, Control C, and then we say Control V, and we want to pull country. So we can pull country here, and you will see it will have error on XSLT. Okay, this was not TH. You see, the third column has come with the country name. Okay, that's how you translate XML to HTML using XSLT. So that similar stuff was getting there, just that the namespaces are complicated in the example. So go through this if you are interested in XML and XSLT. It is kind of old technology. Modern stuff doesn't work on XML anymore. Some places you do make use of XML, particularly, for example, if you're writing SOAP content or if you are heavily into Java, then Java web applications still make use of lots of HTML. For example, an ERP framework like Offbridge makes use of XML-based framework. It's a good one, solid one, but slightly outdated compared to modern standards. It was architected long time ago. So there is nothing wrong with XML as such, just that it is hard to type and there is a lot of repetition in XML. That's why JSON is preferred in web application because it is lightweight and easier to process. And you can make JavaScript objects just like that from JSON objects. So that gives you a layer where Node.js really made it popular. And before that also, if you remember, the Ajax started with XML, but slowly they moved to JavaScript or JSON. So that's quite a bit of discussion we had, and I will end this video here. And in the next video, I will show you example of XML functions, and then we will move on to JSON functions and operators. And it's a big one, 33 pages. Quite a lot of information will be there. So we will go slowly. It may take 5-6 videos to complete the JSON functions and operators. So be prepared for a long discussion on this, or rather read through, not really discussion, read through. So thanks a lot for watching the video, and I'll see you in the next one with JSON, with the XML example, and keep learning and stay curious. Have a great day and enjoy.